Hello, in this video we are going to explore how to use the TechTigers library. In this library will have all kinds of code for our visual display, pathfinding systems, state machine, and more. Today we will explore the visual display part of the system. For this tutorial we are going to use a rev control hub, battery of course, Adafruit Neopixel driver, and an LED display. You can get these LED displays on Amazon. There are tons of vendors for them, and this Adafruit Neopixel is what we use to control them. So if you have all these parts, you can follow along with this tutorial. As far as hardware goes, let's set it up right now. We have our Adafruit Neopixel, which has a connector for the display, a 5-volt power from the control hub, and an I2C port. So we will plug this part of the Adafruit into our LED display, like so, until it makes a nice fit. Then this part will go to the 5-volt power, which is needed for powering this display. And then the I2C can go to any I2C port on your control hub. So we will put it right here. Now that we've connected everything to our control hub, we will power it on and then check the config. On the control hub, go to configure robot, whatever your configuration is, go to control hub, go to I2C bus 0, and put in Adafruit Neopixel driver with any name you want. In this case, we will call it visual display. Once you finish that, you can just save the config. Now that we have our hardware set up, let's go and put the library into our codebase. So let's go and clone FTC robot controller. We'll copy the link. Now we can open Android Studio. Now we can clone the repository and just put in FTC robot controller. Alright, now that we have our FTC robot controller code, we will now install the TechTigers library onto our codebase. We will have a link on our website to do this, but you can also access it through the GitHub. Go to your web browser and look up TechTigers FTC GitHub. Go to the link, go to repositories, go to FTC core. Now click on code and copy the link. Now go to jitpack.io and paste the link in. Here you can see all of the different versions of our library. We will be using the 2.0.0 release. It may be different for you. The steps are all over here, so you can follow these steps or do what we're about to do. Copy this repository for your dependencies. Go to Gradle scripts and build.dependencies.gradle and paste it. Now over here at the bottom, we will paste this implementation. Once you paste it in, you can replace tag with the version number, in this case 2.0.0. This ensures that you can choose when to update this library to the latest version. Once you have done this, click Sync Now to sync your Gradle files and get everything onto your computer. Alright, now that we have the library, let's write some simple code that we can use to display stuff on the display. Let's make a test on mode. We can call this visual display test on mode. Then we can just have it extend the linear op mode, implement methods, and we'll make this a teleop. Okay, now the key thing to understand here is the structure of our visual display code. You have the physical display, then you have something called views, which are inside the code. Views allow you to show different types of information depending on the situation. You could have a view for auto, a view for tele, a view for endgame, and they can all show different things, so you can switch between them very easily. Each view has a bunch of regions inside of it. These regions contain sprites, similar to Scratch, little objects that can be moved around and change colors. These regions take up space on your visual display. Before we write any code for our visual display test stop mode, let's make a few regions first, so that we can actually show something there instead of just a blank screen. First, we can start with the X region, which will just show a class. So let's make class region. And this is going to extend display region, which is just a general class for all of this. Now, we are going to make an X sprite, and we will call it class. And we will also make an array of sprites. Now, we will make our constructor. Okay, so what I have done here is make a constructor that accepts an X and a Y. And it'll call the superclass for the X and the Y, and also give this class region a width and a height. The reason is because on our display, we have to tell our regions where they are going to be located. So if I give this an X and a Y of 0, 0, then the X is going to be drawn right here, because it is 3 wide, 3 tall, at 0, 0. We can adjust where this region is in our view, which we will get to later. Alright, now we are going to define the class to be a new X sprite. It's asking us for an X, Y, width, and height. Now this X and Y is relative to this entire region. If my region was much bigger, say 5, 5, then I could choose to put this at like 3, 3, or maybe 2, 2, wherever I wanted to. In this case, our width is 3 and height is 3, which is perfect for a small x. So let's fill up this region with the x by positioning it at 0, 0. Let's also give it a width and height of 3. Now let's set the color of the class. I'm going to make it green. Let's enable the class. And finally, we will make sprites equal to a new array of sprites, and we will include class in that array. Okay, now you only need to add code to the update method if you want to change what the sprites do depending on what's happening to your robot. For example, you can make it so that if a color sensor detects a green artifact versus a purple artifact, you can show a different color on the display. In this case, just for this demonstration, we do not need any code in the update loop, but this is something that you can add if you wish. And finally, for the getSprites method, we are just going to return this sprite. So we can do this dot sprites, and that'll give the class to whoever calls this method. Okay, now that we have our class region with the one class sprite inside of it, let's put this inside of a view. Let's make a new view called test view. It'll extend display view. And now in the constructor, we will call super of new display region. And this is going to be an array. And in this array, we will just make a new cross region at 0, 0. And we will add the semicolon. What this is doing is making a new view for our display and putting a cross region object at 0, 0. So this cross should be all the way at the bottom left of our screen. Finally, to test this, we have to add this to our op mode. So let's go back to our op mode. And let's just go into the run op mode and start defining everything. So Adafruit Neopixel, we can just call this driver is equal to hardware map dot get Adafruit Neopixel dot class, and we'll call it visual display. This should be the same name as in your config. Now let's initialize our driver. We can do driver.initialize, and now it's asking for number of LEDs and bytes per LED. Now for the number of LEDs, you need to figure out how many LEDs you're trying to control. If I go back to our view over here, right, this is our matrix. It's 8 by 30. Yours may be different, so please count how many LEDs are in your matrix, because this affects how the sprites are displayed on the display. Because we have 240 LEDs, we will put 240 over here, and the bytes per LED can remain at 3. Now let's create our test view. So test view is equal to new test view. And now we can create a visual display, which is what we will use to control the hardware. Visual display equals new visual display. And we will call it with a driver and a view, visual review. Now let's wait for start. And while the op mode is active, we will update the visual display. Now let's run the code. Alright, now we can just go and run the op mode. And there is our X, right there at the bottom. So this code is working as expected. Now let's add a few more sprites. The cool thing about this system is that it's very modular. I can go into my test view and just make a new cross region at 27, 0. And it should put the same thing on the other side. Now let's make a new region for a rectangle. For example, in Into the Deep, this could represent a sample. Let's make another region. Okay, we can do private rectangle sprite. We just call it block. We'll actually make it private final. And private final sprite sprites. And in the constructor, public block region, give it an X and a Y so that we can control where it is. Super of X, Y, and now we have to control how big this region is going to be. In this case, I'll make it represent a block, so I will make it have 4 pixels wide and 2 pixels tall. Now we can define our rectangle, so block is equal to new rectangle sprite. We'll give it, let's see, we'll make it at the 0, 0 because our region is only as big as our block. We can give it a width of 4 and a height of 2. Set the color. In this case, let's make it blue. And we can enable the block. And finally, let's define what sprite is. Okay. Now, again, nothing in the update loop, but you could have it, for example, look at what the color of the Into the Deep block was in your intake, and then reflect that on the display. And in the getSprites method, let's remove this and return this dot sprites. Now we can go to our test view, and let's add a new block region. Now, if I go back to our display, we have a class over here. We will have a class over here. Let's put a block somewhere in the middle. So let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's do 13, 14, 15, 16. So the block will be right here. I know it's not perfectly in the center, but that's okay. We can do 13,000. Now all we have to do is run the code. Okay, let's run the code. There we go. Now we have two crosses and a block over here. So I hope that this tutorial has been helpful for learning how to control your display using the TechTigers library. If you need more help, you can contact us via email, YouTube, or our website, where we will have more resources on this topic. Thank you.